we will be running a bit faster. Okay, anyhow, yeah. So moving on. Speaking about the recursion, we all have spoken much about the recursion in the lower sections or lower classes, and what we see about the recursion is whenever a function calls itself repeatedly, right? Whenever a function calls itself repeatedly, then we call it as a topic of recursion. So Java supports recursion here. Recursion is a process. Okay, so recursion is where a process of defining something itself again and again, right? It calls itself again and again. That means inside a function, there is a method, there is a statement which is calling itself. That's called as a recursion. And as it relates to Java programming, recursion is the attribute that allows a method to call itself. A method that calls itself is called as recursive method. All right. So a classic example is our factorial. As we all know, factorial refers to if I say 3 factorial, that means it is 3 multiplied by n minus 1, that is 3 minus 1, that is 2 again multiplied by 2 minus 1, 1. So once it is 1, then you have to stop it. Okay, so that means you have to check whether is my n 1, if not, subtract it by 1, right? So a classic example is about the factorial. We'll see the example of factorial, how it works. Okay, so here when we see, we have a main class which is called as a recursion, and we have a method, main method here. Okay, so we are creating one object f belonging to the class factorial. So there is a factorial class. Go to factorial class. Okay, in the factorial class, do we have any constructor? Do we have any constructor in this factorial? As of for now, we do not have any constructor. All right. So do we have any instant variable here? Instance variable we do not have, but we have a member function. A member variable is not there. We have a member function. So what's the member function? It is fact, and that fact is taking a value some n. Okay, and inside that we have a value which is result. Okay, so if my n is double equal to 1, that means if my value itself is 1. So if a user calculate the value of, calculate factorial of 1. Okay, my n value is 1. So what's no more calculations is further needed. So it will straight away return 1. This is something called as a terminating condition. Terminating condition. So always remember, in any recursive function, care should be taken for two important questions or two important conditions. The first one is a recursive function should always have a base condition. Then a recursive function should always have a terminating condition. If you do not have a proper terminating condition like this, you will end up in infinite loop. You will be ending up with infinite loop. Always make sure that you have a proper terminating condition. Okay, so what is the base condition here? Base condition is this: result is equals to fact of n minus 1 into n. So how do I know that this is a base condition? Base condition will have the function calling method, right? The particular base condition will be calling the same function. Okay, so that will be the base condition. And what will be the terminating condition? Terminating condition is where it has to come out of this particular function at some time. If it is not coming outside, then it will end up in infinite loop. Okay, So yeah, that's about the recursion. Maybe we'll look into the example how it works. And okay, what happens next? So result equal to fact of n minus 1 into n, return the result. What does it say? So well, let's take an example here and we shall solve. So system.out.println factorial of 3 is fact, that is object dot fact method, that is the method of 3. So that is what the value is. Okay, so we are sending 3 as a value. So this 3 will land up at this particular method fact int n. So here my value of n is 3. So main value will be 3. Int result is just a common variable, local variable which we call in our term. We check, is n equal to 1? No, it is 3. So this will be not executed, right? So it comes to here, result equal to fact into n minus 1 into n. So what is fact of n minus 1? You are sending it again. That means 3 minus 1 is 2. 2 you are actually sending it again and you are multiplying with, what is this n? N is what? N is 3. So 3 I have here. Then again this fact of n minus 1, 2 will be sent here. So again, is n equal to 1? No, it is 2, right? So this will not be executed again for the second time also. Then it comes here, result equal to fact of n minus 1 into n. So again, what is n minus 1? N minus 1 is 1 into what do we have here as n? So 2. So this was divided into in this way, into 3 will be there without any change. So next it comes back, it calls again fact of n minus 1, it comes here. What is my n value now? New n value is 1. Is n equal to 1? Of course it is 1. So return 1. So here in this it will straight away return 1. Then it has the same value. So ultimately when you subtract 1 here, 1 into 2 is 2. So 2 into 3. So what is 2 into 3? 2 into 3 is 6. So my result ultimately will be equal to 6 and it will send the result back. That 6 value will be sent back. It comes and resides here. So factorial of 3 is 6 is what it will display. Similarly, the assignment will be with respect to this program for you guys for the factorial. How I explained with this particular example, taking an example, I want you people to explain it on your own for factorial 4 and 5. That would be your assignment for today. So if you people have any doubts in factorial, kindly let me know, and recursive function, let me know. So I'll be just moving on with the recursive function. So the beauty of recursive function is as the function is calling itself again and again, it is having more pace, right? It is executing, it is executed faster, right? So whenever I say executing faster, we have some timing mechanism when it comes to the algorithm, okay? But we also have something called as a complexity, right? We also have some complexity. More variables are involved here. The same variable again and again it will be involved. So care should be taken here very carefully whenever you're dealing with the recursive functions. Okay. All right. Then next we look into something called as access control. So access control in the sense we have something called as security when it comes to the objects, right? So what do I mean by security in Java? So we provide public, private and protected, which are a type of security for our access. Okay, so we don't want, they're based on your requirements actually, right? Based on your requirements, the first requirement is, do I need to allow those information to my methods, to other methods? First thing, other methods of the same program, right? The second option is, do I need to allow my information to the methods of different program? So methods of same program is the one, methods of different program is the one. The third one is it available for everyone? Right, so we have three types of here, or we should not be available for anybody, sorry, because the first one is the data available for the same program, the data available for different program, and the third one is the data not available to anybody, even for the same program or for the different program. So in this case, we need a mechanism, something called as access control. So it is the work of the programmer who actually gives the access control towards the data, because when it comes to the object, all objects will be secured very tightly, and it will not allow any breach unless until the programmer is giving it. So Java access specifiers are three types: public, private, and protected. Java also defines a default access level, which is protected, applies only when inheritance is involved. So we'll try to understand what protected is, because that concept is mainly involved with the inheritance and we have not discussed it yet. The others access specifiers are described next. That's what it says. So let's begin with two things. One is public and private. So we have to be very careful when to use the public and when to use the private. If wrongly used with the public and private, you will end up in giving false permissions to others or no permissions to the genuine person. It's in that way. You will give the access to a wrong person, or you're not accessing, or you're not giving permission to of access to the right person. So if misplaced with public and private, always make sure that you give a proper access control. So when a member of a class is modified by the public specifier, then the member can be accessed by any other code. Simple. Public means it is available for everyone. So public means it is available for everyone. Who are everyone? Who are everyone? Everyone is member functions who are in the same class, member function who are in the same program. Okay, so now you can understand that why do we have a main method as public. So why do we have a main method as public? Main method as public. So here we have a main method and it is public. Why? Because this main has to be called at the initial place itself, right? We need to call it in the beginning itself. If I make it as a private, then nobody can call it. Okay, so it's always been preceded by the public specifier. It is called by code that is outside the program. If you make it as a private, nobody can call it. Only those methods which is belonging to the same class can access the private members. So that is by the Java runtime system. When no access specifier is used, then by default the member of class in public within its own package. So if you are not specifying anything, by default it will be public. Okay, then by default the member of the class is public within the same own package, but cannot be accessed outside the package. Outside the package refers to, this is my set of programs, and one program has a main in it. And this particular main method, if it wants to access another program which is in the same package, this is a package 1. This is package 1. In this package 1, I have many terms. If you want to access any member variable from another package, this public will not work. This public allows within the same package, within the same program, within the same class. All right. Next, in the class developed so far, all methods of class have used the default access mode, which is essentially the public. As I said, if you're not specifying anything, by default it will be understood that it is public. So however, it is not what you will typically want to be the case. Usually you will want to restrict access to data members for the class following access only through methods. All right, so if you want to give the information, if you want to take the information, if it is public, no issue. If it is public or default, then we have no issue. But if you want to restrict that particular value for the public methods which are accessing it, then you have to make it as a private. So whenever it is a private, it is towards like a private section, right? It is only reserved for those people. So an access specifier precedes the rest of the member type specification. That is, it must begin a member declaration statement. A small example for your public and private can be given or explained here, I guess, throughout this program. So we have public int I, private double j. So we have private int my method int a int b. So here some case. So here this variable I will be accessed by any method within the same program, but this particular double j is only for the same class. Even if it is a function in different class, it will not work. It is only restricted to same class value only. If you want to save something, you have to send it via a method. Then from this method, you have to push the value to here. You cannot straight away push it from outside. That is wrong. You cannot call and it will not give you any access also. That is why you might have seen in most of the programs, in my way of programs, where whenever I am sending any value to a function, the function will get the value and it will assign via the same class. That is because of the security, because nobody should actually gain the access. To understand the effects of public and private class, consider the following program. Okay, we have some program here. What we'll do is we'll copy this and we'll try to run. We'll try to understand. Okay. Fine. So let me comment this. So what does this program say here? I have a class test. Okay, then I have a main class access test. It will give me an error if I'm not using the same class name here. So let's assume, right? So here I have a main method. So main method is creating an object OB, and it is checking, and it is checking with the constructor. Do we have any constructor here? No. So object OB will be created, and this object will have three values, A, B, and C. A is by default. As I told you, default will be public. You can also give a public keyword if you specify it. If you want to specify it, then yeah, B. Then you are also giving a integer value which is private C. So you are saving some value A, B, and C. Okay. So object A is 10, object B is 20. Okay. You have given the value for A and B, 10 and 20 of whom? Of the object OB. Then you also try to set the value OB dot C equal to 100. OB.C equal to 100. So if I use it, it will give you an error. It was giving you an error. Why is it giving you an error now? Anybody? It is giving me an error for C. Why? Because this C is not visible for this particular main method, for this class. To be speaking with respect to the class, this OB.C is not visible for this class itself. Why? Because OB object class may be test. Test C value is actually private. Your compiler will make sure that that C value is not visible for anybody outside its own class. So that's why this ob.c, even though you write it, see to that if it is public, you can use it. If it is private, no. If you want to give a value, then you have to call the method and then push it towards that value. So how do I do it? So ob.set c value, and you are sending 100 value. So there is a set c value. So set c is taking 100 as I, and yeah, this method which is belonging to the same class test can access the private value. So I value which was 100, the I will be pushed to the C value. That is perfectly fine. That is perfectly fine. Similarly, in the next cases also, if you want the values of ob.a, you will be getting ob.b, you will be getting. If you use only ob.c, it will give you an error. Why? Because again that C value is not visible. If you want to see that particular C value, you have to call the method itself. You have to call the method itself. Get C value is one method. So what is it doing? This method can easily get the value of what it is stored in C. Why? Because it is belonging to the same class, right? So what does this do? This gets it and it returns the value, and you will be catching that particular value in the calling method. Okay, so let's run it. So if we run it, maybe 10, 20 and 100 is what we are looking for. Oh, we have some error. What is that error? Okay, many test values have been utilized, I guess. So test one. Anywhere any issue? Let's clean the project once. Yeah. Yeah. So yeah, this is one problem with respect to the Eclipse. Whenever you get errors like these, make sure that you clean the project clearly, so that whatever previously those values which are already utilized, so they'll be cleared and your project will be clean from previously used values. So this is like your garbage collection in your Eclipse. You can use it. Yeah, once I run it, so majorly what I see is 10, 20 and 30 with respect to the values. Sorry, 10, 20 and 100. Okay. So yeah, I think that's about the session for today, which we'll be looking into. And in the next class, we'll be looking closely into the access control. Okay, we'll be looking into this other values. Other concepts. Okay. So yeah, we'll stop at this point.